We'll now look at division of exponents and the rules that we follow for that. And like always, the first thing we're going to do is we're going to look at it when we expand it. So our first example is 4 to the 4th power divided by 4 squared. So we have 4 times 4 times 4 times 4 divided by 4 times 4. Now in order to do this easily, the first thing we need to do is remember how to reduce fractions. If we have something like 8 over 4, we can reduce that to 2 over 1, because what we do is we look at both 8 and 4 and think, well, 4 goes in here twice, into here once. So we have 2 over 1, which is, of course, 2. We can do the same thing here. We have a 4, and we have another 4. Well, 4 divided by 4 is 1, so in a sense, they cancel each other out. And the same thing for this next 4 and this 4. The 4 and 4 cancel each other out. So we're left with the 2 4s on the top and nothing on the bottom. Well, we don't really have nothing, because when you do 4 divided by 4, you get 1. So our result is 4 to the 2nd power over 1, which is simply 4 to the 2nd power. If we do the same thing for our next example, example 2, we have 12x to the 4th divided by 4x to the 3rd. So we'll expand 12, and then x times x times x times x divided by 4, and x times x times x. So we can look at this, and if we start with our x's, we can cancel out, pair them up, and we're left with 1x on the top. We still have our whole numbers, 12 and 4, which they're just simply a fraction. So we can simplify or reduce that. 4 goes into 4 once, and the 12 3 times. So now on the top, we're left with 3x. On the bottom, we're left with 1, which is simply 3x. If we look at example 3 now, you probably notice that this time it's going to look a little different. If we expand it, we have x times x times x on the top, and on the bottom we have 5x's. So if we follow the same pattern and we cross out all of our pairs, this time we're left with only 1 on top, because everything divided by itself is 1, and x to the 2nd on the bottom. And now for our fourth example, we have 5x to the 3rd y to the 6th divided by 10x to the 4th y to the 3rd. We'll go ahead and expand it. We have 5x, x, x, and then y, 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 divided by 10, x, 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 and then 3 y's. So again, we follow our pattern. We can cross out an x and an x. We can cross out a second x. We can cross out a third x. With the y's, we can cross out a y. We can cross out a second y, and we can cross out a third y. And if we look at our numbers, we have 5 and 10, so we can take a 5 out of 5 and a 5 out of 10. So on the top, we're left with 1 and y to the 3rd, and on the bottom, we're left with 2 and x. So if you want to just write that as y to the 3rd divided by 2x, you may. So what do you notice? Well, hopefully you notice that for each of these we can subtract the exponents. That would be our shortcut, is to go ahead and subtract the exponents for each one of these. For the first one we have 4 minus 2, that gives us 2. For the second one we have 4 minus 3, which gives us 1. For the second one the third one we have 3 minus 5, which gives us negative 2. But notice our negative 2 goes on the bottom as it becomes positive 2. And for our last one, we have 3 minus 4, which gives us 1, or negative 1, I'm sorry. The negative 1 for the x's, which means it's on the bottom, and the 6 minus 3 for the y's, so it's on the top. So hopefully you notice what you're doing is subtracting the exponents. Therefore, if you have x to the a divided by x to the b, you can simply go x to the a minus b. Same if it's written like this, x to the a divided by x to the b is simply x to the a minus b. Next, we'll look at zero exponents, or an exponent of 0. So we're going to start by looking at something like x to the 4th. So we see this, x to the 4th, our base is x, our exponent is 4. Our coefficient, even though we don't see anything there, our coefficient is 1. So if really we were going to really be detailed in expanding this, we would say it's 1 times x times x times x times x. Now I know we never talk about the 1, but it is technically there. So if we have x to the third power, or x cubed, that would be 1 times x times x times x. Therefore, x squared would be 1 times x times x. Finally, x to the first, 1 times x. So in each time, the exponent's telling us to write down the x that many times and attach it to that 1. So that means if we get to x to the 0, we'll start with 1, because that's the coefficient. But the exponent of 0 says write the x down 0 times. Well, that means it looks like x to the 0 is equal to 1. All right. That also means if we look over at the three examples to the right, we have 8 to the 0. Well, that means we would write down the 1 followed by writing down the 8 0 times. So it's simply 1. 47 to the 0, start with our 1 and write down 47 0 times. So 47 to the 0 is 1. And finally, dog to the 0, because you know you love your animals, we'll write our coefficient of 1, followed by we'll write the word dog 0 times, so therefore dog to the 0 is 1. Which basically means that, think about it, anything to the 0 power is 1. Anything to the 0 power is 1. So whatever that 0 exponent is attached to simplifies to 1. Simply 1. So now finally we're going to look at negative exponents. Negative exponents. That means we have an exponent that's a negative number. So let's think about again what exponents are. If I have 5 to the third, 5 to the third means I take that 5 and I write it down and multiply it 3 times. So if I have 8 to the negative fourth, that means I take the 8 and I write it down negative 4 times. Can't do that. Negative exponents are impossible to do. So what we have to do is make them possible. And it's really not that hard to do, and you already probably know how to do it. So we'll start by looking at our first example, x to the second divided by x to the ninth. Okay, using the rule, we would take 2 minus 9, and that gives us negative 7. So x to the negative 7th. But if we expand it, that's x, and on the bottom that's, a whole lot of x's. And then we cross out, and cross out, and we end up with 1 on the top and 7 x's on the bottom. Well, what that tells you is x to the negative 7th is the same as 1 over x to the 7th. They're identical except one has a positive exponent. So let's look at the second example. 5xy to the 5th divided by 20x to the 9th y to the 3rd. If we start by taking the 5 over 20 and reducing it, that gives us 1/4. We then look at the x's. That x to the first over x to the 9th, so that's 1 minus 9, or x to the negative 8th. And if we look at the y's, we have 5 minus 3, which is y squared. So we have 1/4 x to the negative 8th, y to the 2nd. Again, negative exponents. But if we expand this, we'll have 5x, y, and then the rest of the y's, divided by 20, and all those x's and the y's. We can simplify the 5 over 20. That gives us 1 over 4. We can cancel the x's, so 1 on top, 1 on bottom. That leaves us 8 on the bottom. And then we can simplify the y's. We have 1, 2, 3 on top, 1, 2, 3 on bottom, leaving us 2 on the top. So again, that tells us that these two things, these two answers are the same. 1/4 x to the negative 8th y squared is the same as 1y squared divided by 4x to the 8th. So hopefully by now you notice how these are compared. A negative exponent, to make it positive, you have to change it from either the top to the bottom or change it from the bottom to the top. So therefore, x to the negative first is the same as 1 over x to the first. Notice if I have x to the negative first, that's really over 1. It's a whole number, so I just flip-flopped it. Or if I have 1 over x to the negative first, that becomes, take it to the top, it becomes x to the 1 over 1, which is simply x to the first. So the rule to remember when you're dealing with negative exponents is to make it positive, you flip it. Flip from top to bottom or bottom to top. And when you do that, the flipping action will make it turn into a positive or the opposite that you're looking for, the opposite exponent.